Welcome to Ask and Learn.
Okay, so if n is equal to 1, then natural log of 1 is 0. So we'd actually be dividing by 0 here. So if there's not a typo, then the radius of convergence and the interval of convergence don't exist, because no matter what you plug in here, you're going to have trouble. But assuming that there's a typo here and this is supposed to start at something like 2, then we could figure this out by using the ratio test to figure out where we get convergence. So I guess I'll use a different variable like c. So we'll do n goes to infinity of absolute value of cn plus 1 over cn, just because we already have a's happening over here. But by cn, we mean this whole thing, including the x values. So this is limit as n goes to infinity, absolute value of x minus a, and then we'd have times bn plus 1 over bn, which is just simplifies to b. And then we have ln of n over ln of n plus 1. So from here to here, I skipped a little bit of the algebra, but I don't think that should be a problem. Just remember that dividing by something is the same thing as multiplying by the reciprocal. Okay, and now we need to figure out what happens as n goes to infinity of ln of n divided by ln of n plus 1. Use L'Hopital's rule here. The derivative of the top divided by the derivative of the bottom. And we're allowed to use L'Hopital because both the top and the bottom are blowing up to infinity. If they were both going to 0, that would be another setup for L'Hopital's rule. So derivative of natural log of n is 1 over n. Derivative of natural log of n plus 1 is 1 over n plus 1. So this is limit as n goes to infinity of n plus 1 over n, which is just 1. So this is 1. So now this whole thing just turns out to be absolute value of x minus a times b. And we're trying to figure out when this is less than 1. So we can multiply both sides by 1 over b. And then we get absolute value of x minus a is less than 1 over b. So x minus a is trapped between minus b and b. So we can add a to both sides. Get a minus 1 over b is less than x is less than a plus 1 over b. Okay, so the radius of convergence here, we'd have a plus 1 over b, and then we'd be subtracting a minus 1 over b. So that's the length of our interval. The radius of convergence, we'd have to divide it by 2. So these a's will cancel, and then we'll get 1 over b plus 1 over b. So we'll get 2 over b, and we're dividing by 2. So our radius of convergence is just 1 over b. To figure out the interval of convergence, we need to figure out whether or not we include this endpoint and whether or not we include this endpoint. So look to see what happens when x is a minus 1 over b, and then we'll look to see what happens when x is a plus 1 over b. So when x is a minus 1 over b, we'd get a minus a will cancel, and then we'd have minus 1 over b to the n. So the b to the n and the b to the n will cancel. So then we'd end up with this minus 1 here. Nothing canceled out with the negative sign. And we're dividing by natural log of n. So this will converge by the alternating sign test. So that's good. When x is equal to a plus 1 over b, if we plug in a plus 1 over b here, a plus 1 over b minus a, we just get 1 over b. So 1 over b to the n will cancel out with this b to the n. So then we just get 1 over natural log of n. And that's going to be bigger than sum of just 1 over n, because natural log of n is less than n, and if we replace the denominator with something smaller, then we get something bigger. By smaller, we mean an absolute value. Okay, and this is the harmonic series. So that blows up, therefore this blows up as well. So this gives us divergence. So we include a minus 1 over b. Sorry, we include that because it gives us convergence, but then we toss out a plus 1 over b. So toss it out, so leave that open. So that's our interval of convergence. And just as a reminder, our radius of convergence was mentioned over here, 1 over b.